Welcome everyone to today's webinar on powering 5G 6G technology. My name is Priya and I'm the marketing lead here. Today's talk will be about 15 to 20 minutes followed by Q&A. If you have any questions, you can type them in the Q&A box and we'll get to them at the end of the talk. The webinar is being recorded and we'll send you an email with the webinar link in a day or two. So now let's meet today's panelists. We have Craig Polk, who's the product development manager here at VTEX. Before joining VTEX, Craig was at Bell Labs and Nokia, where he led innovation across several industry sectors, such as healthcare, education, and environmental science. Craig is a graduate of Stevens Institute of Technology and Purdue University. We're also joined by Rich Whitty, sales manager at VTEX. Rich graduated from West Point in 1987, and after serving in the Army, he started on a career selling capital equipment to the semiconductor industry. Rich has many years of engineering and sales experience and joined VTEX earlier last year. Right, Rich, over to you.
Okay, thanks, Priya. I guess we're going to be talking about 5 and 6G today, and Craig, being from Nokia, you're the perfect panelist for this discussion. And maybe you can look into your crystal ball and start us out on the presentation.
Yeah, sure. Thanks, Rich. I'll try to see how many of these forecasts that we do come out to be true. Before we start getting into our forecasting area, we're going to talk about where we are right now in 5G space. So where we look at where we are today, we see some very interesting trends in the global environment, specifically how South Korea is leading a lot of this innovation. And we find US also towards the top as well, but only having about 20% availability in recent studies for its 5G compared to its other technologies. And one of the things that we're really interested in looking at is where 5G gets put in the radio spectrum, in the air spectrum. So there's been different service providers that have been bringing out 5G, some in the millimeter wave and lower band. And just recently, last year, we saw the launch of C-band spectrum. And also 3.5G spectrum coming out this year as well. So we're expecting to see a resurgence of more 5G sites and capabilities as we move forward. So looking at the United States, there's 3 major players that are expanding into 5G. The industry has really gone looking at urban areas and high cluster and density of spaces and expanding from that. So we're really expecting the rollout to continue like that. As we're moving across the next couple of years, these 3 service providers, they're really looking to break the coverage of 200 million people across the United States. And we're expecting the subscriptions to continue to increase as that more cell sites and more capacity is grown.
So am I reading that correctly? It's forecasted subscriptions are forecasted to double in the next 2 years?
Yes, we're seeing a very large trend, and that's where the forecasts are going into the next 2 years, to really doubling the amount of subscriptions in the 5G service offering. So that kind of brings us into, as more of this capacity is coming out because of more subscriptions, more people getting the higher capacity, moving into an Internet of Things, when machine-to-machine communication is going to be becoming much more commonplace. Where does fiber kind of fit into this? So fiber is really in multiple areas of this network typology. So if we kind of look at it in the individual, from our RF space moving back into the core network, we see that fiber plays a huge role in our front haul which is at the end or last mile of our connections before our RF signal. We're also seeing a new area, which is the mid-haul, that came about because of 5G and the different distribution architecture that the 5G RAN is using. And lastly, we see the backhaul connection, which has traditionally been in the area of fiber. So,
Sorry.
yeah, I'm sorry, Rich.
Yeah, I had a question. I was just curious why the CPRI protocol, it just is strange to me, not being from telecom, why they're using different protocols, front haul, mid haul, and back haul. They're all different protocols. And I'm just curious how that came about.
Yeah, that's a good question. So the backhaul and the mid-haul came from an international standard, from a 3GPP standard, whereas the front haul, especially in 3G and 4G, was developed through this common public radio interface, or CPRI. So it was really a group of companies in the industry that got together and defined this protocol. There was some early discussions about if it would be open or not open, and it kind of moved to more of a proprietary nature. So it really forced some of the customers in the service, in the mobile service space, to have to get these solutions from a single company, because the front haul had some very vendor-specific attributes to it. So it's kind of to really maintain some control over these network rollouts of what equipment you were able to communicate with. So that was a good question.
That's great.
And all this communication, it runs over fiber. So we're really seeing how fiber goes everywhere, right? Fiber to everything, to businesses, for not only just backhaul or for data centers, but throughout the telecom space. How it connects DAS units, or small cells, femto cells, or fixed area networks such as the macro cells that we see along the highway on poles. So fiber is going all the way from the central office all the way to the cell site. It plays a very key role in being the connection of these different areas of the telecom network. So if we kind of dive into the different areas, so first looking at the front haul, we saw 5G kind of just piggyback on some of the 4G connections of CPRI, which was at the rate 7 and 10, which is a 10 gig or a 25 gig. But there was limitations in that, because as 5G was looking for higher capacity, especially in millimeter wave applications, you couldn't really get the connections from the radio heads to the BBU to be able to push as much traffic as you wanted. So the architecture kind of developed into either offering parallel interfaces where you would have multiple CPRI connections, or this evolution of an enhanced CPRI or an eCPRI, which would bring out even faster rates. So they move into a different 10G protocol, and we see most connections right now are actually using 25 gig. But there are transceivers that support 40 as well as 100. But right now, the industry kind of maintains a 25 gig connection. And one of the other things to really mention here is in a lot of phases of these architecture, this equipment is outdoor. So having industrial temperature and environmental compliance is very important based on the install base. So we step back a little closer to the core and we talk about the midband. This is a new area that came out because of the 5G RAN architecture, of how the centralized office kind of broke over and included a different distribution setup. And in here, we require a little bit more capacity just because of the amount of front haul connections that are coming to the distribution base stations. And so it can collect all of those different streams. So we see a lot of like 50 gig and 100 gig in this area. but again, allowing for enhancements to 200 and 400 gig as well. As the mid-haul pushes these connections back to the centralized office and into the core, this is where we really need the greater capacity. So we see 200 and 400 gig optics used a lot more in this area of the network. So through all of these different parts of the RAN architecture, there's two things that are of vital importance when you're really looking at your fiber optics. So first, there's initial test for compatibility and install in different stages are very important, but really on the early stages. A lot of the front haul connections or the cell site connections are installed before, sometimes weeks or months prior to having connectivity back to one of the distribution areas. And the reason for that is just because of the scheduling of the work that's needed to do rooftop installs or to do tower climbs. And it can be expensive if repeat visits are required. So making sure that the test of the transceivers and the fiber cables that are used in these front haul connections is really vital. Also, as we go through the front haul and back to the different aspects of the network, we really want to be concerned with the monitoring. What kind of monitoring capability is there? So this is really important to reduce downtime. As we all know, having mobile connectivity is really vital, especially for things like emergency services. And so we're always pushing for some type of 3 nines or 5 nines type of uptime for the network. So being able to monitor that is crucial. And it also increases the efficiency of the network, being able to make sure that we have the correct amount of distribution BBUs and radio heads and coverage and capacity throughout the network.
So now it's time for the forecast. So I guess we'll go back to your crystal ball. Appreciate it.
Yeah, so we'll see what our VTEX crystal ball is telling us. So what we're kind of looking at, some of the industry trends in fiber optics. Some of it relates to the backhaul. Like, where do we see the backhaul connection going? Because we see countries such as India that's a little behind with 5G, and they're looking at some of their 5G standards and incorporating that into the 3GPP. So we're expecting kind of like a resurgence of the need for backhaul, especially worldwide. And so there's a couple options that are available. The dominant one is definitely fiber. We see a lot of companies continuing to invest in fiber out to the backhaul, mid-haul, and front haul. And so there's some other areas that are being looked in also, such as some free space optics and the use of millimeter wave for the backhaul, or so that's the LOS, or the line of sight, which is not to be confused with the frequencies that are generally around 24 gig to 40 gig for the millimeter wave applications for the RF portion. And while some of these are increasing, but we see that fiber is the area where most service providers and installers are continuing to look at.
So is line of sight, I'm sorry, is line of sight basically due to the wavelength? Is that it's too small of a wavelength to bend around anything substantial?
Oh, yeah, thanks, Richard, for reminding me about that point. So one of the areas that are being looked in for the millimeter wave and the line of sight is really for the characteristics, the physical characteristics that these millimeter wave connections can support. So generally, they're really good for providing high capacity, but in short runs, right? They can't really get too long because of the size of the wave. And so as you increase the or I should say, as the frequency increases and the wavelength, we see the reduction in wavelength, more capacity can be handled, but it typically means that there's going to be a shorter distance traveled, and then also attenuation becomes a great concern for like penetration into buildings or past obstacles. Can really impact the signal. So a lot of the backhaul is direct line to sight or point to point. So it's that's one of the advantages that fiber has, the ability to route it through areas and buildings such as suburbs or urban areas where things that may not have direct line of sight access, where it's very beneficial.
Thanks, Craig.
So one of the things that we are seeing occurring is really the increase of WDM optics. So wavelength division multiplexing is really took off in 5G, and we're continuing to see that trend both in the, I should say, all in the backhaul, the mid haul, and the front haul. The use of CWDM, DWDM, and LWDM, being able to really get enhanced capacity out of fiber lines that are run. So being able to send more data over increased amount of wavelengths over the same fiber is becoming beneficial through the 5G RAN. And we're kind of seeing, as we go into the future, into 6G, that's going to continue to develop, to look for increased capacity on infrastructures that are already in place. And we see optics coming out being used in the telecom space that are primarily used in data communications right now, such as the 800 gig and the 1.6 terabyte. And there's been some discussion on the use of coherent optics and how this can also translate into the telecom space for providing these greater capacities and these greater rates. More on the RF side, the RF connection, there's been some re-emergence of OWC, or optical wireless communication, but it's mostly in the area of how you would use free space optics, maybe for a large distance connection, and then also some visible light communication for much shorter distances, for kind of a comparison against the millimeter wave that's used for short distances. So some of that work is going on. We're interested to see if that's going to lead anywhere in the 6G space. And all of this analysis has a real big focus in the reduction of latency. So while increased capacity is very important, latency is a huge factor, sometimes more important than capacity, especially when we talk about things such as machine-to-machine communication and IoT. For example, in the automotive industry and autonomous vehicle, the ability to communicate from different devices sometimes requires greater connection times, greater connection speeds than the amount of data that you really need to send. So looking at reduction of latency is a big topic as we move into the next decade into 6G. And the crystal ball kind of shows that I wouldn't really be surprised if we see a further change in the like the ORAN architecture and the Open RAN architecture, where a new element such as mid-haul that we saw in the 5G kind of emerges in the 6G. So this might be a different protocol that could come out to really allow for the whole interconnect of a lot of devices that people use in different ways. So those are some of the things that we see going on in the industry for the next 5 to 10 years as 5G and 6G kind of roll into each other, and also a little early on for this year as the different C-band and 3.5 gig installs really start to happen, where we're going to see that large subscription jump, and that really means the fiber optic network is going to have to grow to match the need of the subscriber base.
Thanks, Craig. Excellent
Yeah.
information. Thank you so much. So I guess if anybody has any questions for Craig, please go ahead and feel free to submit any questions that you may have. I guess it was very informative. Nobody has any questions, so it's a good job, Craig.
I got one question. I know one of the things also that's come up about the enhanced use of fiber in the telecom space kind of deals with security, since a lot of these connections, are concerned with the security, cybersecurity. So, fiber offers a greater deal of security than the old traditional copper based connections. And so that's also an advantage of that. I do see that there is a question on there related to the high performance computing use and how the telecom space might be getting into that, or how that kind of meshes. So they're starting to kind of mix together in unique ways, as we're seeing more devices that are don't really need to be connected directly to each other, and having the availability to connect through air interfaces and have this higher capacity. So we're seeing more of a level of application work that was traditionally done on high performance computing moved closer to the end user. So we can see how things like edge computing are starting to kind of redefine where the majority of processing of some things are being done, and kind of split throughout the network, and how that kind of integrates into the whole cloud infrastructure of telecom and datacom merging together. So hopefully that answers your question.
Thanks, Greg. So that was very informative. And I also dropped a link to the past webinars in the chat for everyone. So if you want to watch our previous webinars or maybe forward it to your colleagues, please feel free to do so. Once again, thanks everybody for joining. And I'll be sending an email out to you in a day or two once the webinar is up on our website. Again, thanks, and have a great rest of the week.
Thank you.
Bye.